All right, guys, very good evening, everyone. Welcome all of you once again. Very good evening. So, here we are again in another session of practice on organic chemistry. Today's topic, we are going to continue the discussion on pericyclic reactions. And guys, there are some really important pericyclic reactions, some examples that we want to discuss. Although ये टॉपिक इतना ज़्यादा वास्ट है कि जितने क्वेश्चन प्रैक्टिस कर लो उतना ही कम है. And combining, only if I combine all of your previous year questions in CSI net, still there will be a lot of questions only in this topic, pericyclic. So majorly it has three different subtopics. एक तो हो गया cycloaddition reaction. उसके भी अगर उसके भी subtopic में जाएं तो it is very vast. Then there is electrocyclic reactions. Then there are sigmatropic reactions. इसके side में there are some group transfer reactions, chelotropic reactions and so on. But majorly ये तीन reactions होते हैं, cycloaddition, electrocyclic and sigmatropic. Okay, so I hope that you have a little idea about all of these things. फिर से हम अपना practice start करते हैं. This is our first question for today, which was asked in a recent paper. ठीक है, ये देखो क्वेश्चन बहुत इजी है, डायरेक्टली बुक से उठाया हुआ है, CSI नेट में आया था and taken from Caruthers. The intermediate A and the major product B formed in the following reaction are. Okay. Very good evening. Very good evening, Anvay, Shubhadeep, Yojna, Omkar and everyone else as well. सभी को good evening once again. Okay. चलो, let's try out this question. Very nice, very easy, very nice. थोड़ा सा tricky है लेकिन. Yes, Anvay, I said थोड़ा सा tricky है. तो एक बार अच्छे से देखो. So you realize reduction है और एक cyclization है, right? You realize that this is this only. But what kind of reduction, which cyclization, that has given us 4 options to select from, isn't it? तो इस question में कुछ तो बात है. बहुत सारे, in the exam also a lot of students selected number 1 and got the answer wrong. Yes. So why should we be careful? What is the Lindlar's catalyst? Yesterday only we have seen where when we are doing catalytic hydrogenation, a catalyst poison is used to stop the reduction of the alkyne to alkene. Okay. So this we have understood कि this alkyne, both of these alkyne are going to be reduced only to alkene. But what is the stereochemistry of the product? It should be a cis alkene or a Z alkene. Yes or no? Exactly. इसको Z alkene या cis alkene बनना पड़ेगा. In option number 1, the trick part is that both the alkenes are written in such a way that you will feel कि this is cis alkene but this is not. ये देखो, ये कौन सा फॉर्म है? ये ई एल्कीन का कैसे लिखा हुआ है? ई एल्कीन का एस सिजॉइड फॉर्म है. यस और नो? इट इज द एस सिजॉइड या एस सिस फॉर्म ऑफ द ई एल्कीन, ई डाइईन. व्हेन टू ऑफ द एल्कीन्स आर रिटन इन सच अ वे, so it is the schizoid form जो हमें Diels-Alder में चाहिए होता है, isn't it? But it is not the cis alkene, right? So we have to be careful. तो ये हो गया यहाँ से गलत. ठीक है. Now, which is a cis alkene? These are cis. Okay. This one is a cis, but the other bond is trans. तो ये bond trans हो गया, गलत हो गया. Now, this is also cis only. This one is also cis. लेकिन गड़बड़ क्या है? If you are doing a cyclization, let's say we have done the reduction over here. Let's say we have got either 2 or 4. Okay, because the other this bond, this is going to remain trans only, that is not changing. So ये trans यहाँ पे भी रहेगा और ये trans इधर भी है. ठीक है, conformationally it is rotated in option number 2 and 4. What is the difference? Now we are heating it. So if we want to do any kind of cyclization, let's say in the presence of heat, if we are using 4n plus 2 thermal ring closing, तो ये हो जाएगा disrotatory motion. Disrotatory means when there are two groups which are, let's say, like this. तो ये hydrogen है, ये यहाँ की तरफ जाएगा. So both of them are going to be closing the ring in this way. ठीक है, या तो हम एक काम करते, पहले हम कराते 4n ring closing. ठीक है, if you are doing a 4n thermal conrotatory ring closing, how is it going to be? See, there are two hydrogens in this way. Okay, both the groups are on the same side. So same side conrotatory will give you trans. ये एक rule है, ये एक simplification वाला rule है. Opposite disrotatory is going to be cis, ODC, and same side and conrotatory will give you trans. Okay, so ये यहाँ पे both the hydrogens are basically opposite, so conrotatory motion is going to give you a stereochemistry like this. ये देखो इस तरीके से. पहले ये हमने 8 पाई रिंग क्लोजिंग कराया है इधर, and opposite and conrotatory are going to give you trans. So basically ODC, SDT, OCT, दो वेरिएबल चेंज होते हैं ना एक साथ में. ठीक है, तो दो वेरिएबल चेंज हुए, ये वाला हमने रूल ले लिया, यहाँ से हमने O को सेम रखा, D को C कर दिया, तो C भी T हो जाएगा. Only two variables are going to change at one time. Okay, so that's why it is going to be trans over here. ये trans हो गया. After the ring closing, first you did a 8 pi ring closing in which you got the two groups to be trans to each other like this, and the pi electron density is like this. Two of the hydrogens are in this way. So first you did 8 pi ring closing. Okay, yes, उसके बाद में हमने क्या किया? Disrotatory motion. Disrotatory motion, these are opposite. Opposite and disrotatory motion will give you cis. So both the hydrogens are cis in the final product, option number B, because both the reactions are taking place in the presence of heat. So 4n plus 2 thermal will also give you disrotatory motion. तो आंसर इसका है 2. D गलत क्यों है या 4 गलत क्यों है? Because guys, whenever you want to do a 8 pi ring closing, you cannot have the bonds to be trans. ये वाले bond कभी भी trans नहीं हो सकते. Ring closing will not happen in this way. So that's why it is wrong. चलो moving onwards. बहुत easy question है ये. This is also from Caruthers only and it is very simple. चलो try this out. Good evening, Logesh, Prasad, everyone. Welcome everyone once again. युवराज, भवधारिणी, वेलकम ऑल ऑफ यू. जो भी मैसेज कर रहे हैं और जो नहीं कर रहे हैं उनको भी वेलकम. Okay, this is also a little bit tricky. Only a little bit though. There are two double bonds which can behave as a dienophile. Which double bond will behave as a dienophile actually in a Diels-Alder reaction? Only that much is the question. Diene का LUMO. Okay, so basically, see, the dienophile, LUMO किसका लेते हैं हम? LUMO हम लेते हैं the one who needs electron density. Lowest unoccupied molecular orbital must be lower in energy. It must be close to the HOMO of the diene. So we need electron deficient dienophile, isn't it? हमें electron deficient चाहिए. ये तो methoxy है यहाँ पे. So this methoxy is going to give the electron to this alkene, which means this alkene will become electron rich. We need electron deficient dienophile. What is the characteristic of a dienophile? That it has to be electron deficient. So which side is going to be electron deficient? Yes, this side which has the methyl. बहुत easy question है. So this side is going to react. Answer is option number 2. It cannot be trans. How can it be trans? 3 is wrong. This is also wrong. बिल्कुल trans नहीं हो सकता. Both the hydrogen and the methyl are on the same side. So that's why they will still remain on the same side. Cycloaddition is stereospecific. तो इसका आंसर होगा 2. Yes, dienophile should be electron deficient. That is why it is attacking from the more electron deficient side, not the electron rich side. That easy question. चलो बहुत easy था ये. आगे चलते हैं. Yes, what do we see over here? देखो, there are two steps. First step में chloroform and heat is given. Second step में methanol is given. What can we think of? Yes, everyone, stereo is very important, but here in the question, mostly the regio and the stereo is fixed. Yes, hello Yash, Yuvraj, Mohit. Yes, correct. Bhavya also correct. Okay, so see guys, how do we place the diene and the dienophile? ठीक है, we usually follow one convention. According to that convention, we place the, I'm just writing this as OTMS. Okay, so we usually place the diene on the top क्योंकि ये heterodiene है यहाँ पे और हम dienophile को below लिखते हैं. So I write the dienophile below in such a way that it is going to be endo. The major part of the molecule is endo, isn't it? It is going to be like this. यही तो है endo selectivity. These two carbons are going to react. ये क्या करेगा इस तरीके से attach होगा. This is the endo selectivity. So if we are checking the endo selectivity after the ring formation, let's say There is a 6-membered ring formed like this. The hydrogens are going to be both above the plane, and this 5-membered ring is going to go below the plane in this way. Alright, there is a double bond over here और ये हो गया है OTMS या OSIME3. ठीक है, it is like this. Where is this methyl? Now this methyl, see, since there is a hydrogen, the hydrogen is pointing in the same direction as these hydrogens. That is why this hydrogen will be above and the methyl is below. Okay, सिर्फ इतना हमें ध्यान रखना है. Now, in your question, sometimes the enantiomer is also given. In the enantiomer, how the enantiomer of this molecule is going to look like? Enantiomer में all the hydrogens will be below and one methyl will be above. Isn't it? Look at this. All the hydrogens are below. Look at option number 4. Option number 4 में दिख रहा है all the hydrogens are below and the methyl is above. In option number 3 also, all the hydrogens below, methyl is above. But it's not the enantiomer, thoda change hai. So we will think about change. What is happening? Dekho. What is methanol doing in the next step? Methanol kya kar raha hai? Yes. Methanol is basically helping this group. It is going to attack over silicon. It is helping this group take away a proton. I think it's going to be methanol and a little bit of acid, because acid के presence में ही ये reaction होगा. Hydrolysis of silyl vinyl ether. ठीक है, वैसे तो ये amide बन गया है. It is not a pure ether. Vinyl ether है नहीं ये, because there is a nitrogen, but it is going to form an amide, a substituted amide. Okay. So this is our answer. Very very simple. बहुत इजी है. चलो हम एक ही कन्वेंशन फॉलो करेंगे, उसी के हिसाब से हम प्रोडक्ट लिखेंगे एंड देन वी आर गोइंग टू कंपेयर द स्टीरियोकेमिस्ट्री टू द ऑप्शंस, राइट? So in the first and in the second option, the stereochemistry of the hydrogen and methyl are on the same side. That's why they are wrong. They should be trans. And here also it is trans. Okay? The junction two protons should be on the same side. वो देखना है बस. फिर आगे चलो, ये आ गया carbonyl. This is an amide. So 3 is our correct answer. Got it? Even if we don't have this nitrogen, अगर हमारे पास ये nitrogen नहीं होता and we have this part of the molecule, ठीक है, जब भी ये चीज होती है, this is silyl and vinyl ether, so in the presence of acid you are always going to get this hydrolyzed to form the ketone. ठीक है, इस तरीके से कीटोन बन जाता है. यहाँ पे, यहाँ नाइट्रोजन है तो अमाइड बन गया. ऑल राइट, यस, वेरी सिंपल. लेट्स मूव ऑनवर्ड्स. ओके, सो अगेन the stereochemistry is more important over here, guys. What is this? Is it a intramolecular reaction? Yes, guys, how are the questions today? Are these questions too easy or too difficult? ये questions सभी को कैसे लग रहे हैं? और moderate? No, because all these questions, I regularly made everyone do these kind of questions in the plus sessions. जो भी मैं अनअकैडमी में क्लास लेती थी वहां पे हम ये करते ही रहते थे इस टाइप के क्वेश्चन। तो मुझे नहीं लगता सबको टफ लगने चाहिए, बट ठीक है, क्योंकि एग्जाम में भी ऐसे ही आएंगे ना। ऑल राइट, 3 और 4। यस, फॉलो द एंडो सिलेक्टिविटी ऑलवेज। भले ही इंट्रामोलिकुलर रिएक्शन हो, still you have to consider the endo selectivity. All right, so if we are doing endo selectivity, let's say, even if we are trying to write the dienophile side on the bottom, ठीक है, तो dienophile में कौन है? There is this carboxylic acid as well as this carbonyl. Both of these are on the same side of the double bond, isn't it? They are on the same side of the double bond. So I'm writing this double bond over here, ठीक है, and I'm writing this acid over here, COH. Methyl goes outside. Also, फिर अगर मैं ऐसे लिख रही हूँ तो मुझे ये वाला जो कार्बोनिल है ये भी मुझे ऐसे लिखना पड़ेगा. I have to write it inside because it is on the same side as the COH. Is it possible? Can I write it like this? It is only possible when the molecule is going to form a 5-membered ring. Questions are good, only missing the poll. Yeah, on YouTube we don't have poll. That's the only thing. But I think it's more important to do the questions, isn't it, than having the poll experience. That's why you are here. So, okay. You'll get the poll too very soon. All right. चलो, ये भी करेंगे गाइस, सब कुछ होगा, क्रैश कोर्स भी होगा, टेस्ट सीरीज भी होगी, सब कुछ होगा. मुझे 2-3 दिन का टाइम और दे दो. इतना टाइम दे दिया है तो और 2-3 दिन का टाइम दे दो, ठीक है. चलो, so yes, now let's do the cyclization. All right, so once it forms a 6-membered ring, these two hydrogens are pointing in the outward direction. That's why इस मिथाइल को हम लिखेंगे below the plane. The hydrogen over here is above the plane. This hydrogen is also above the plane. The 5-membered ring that forms, this is going to be below the plane. Okay, ये below the plane बनने वाली है 5-membered ring. Okay, all right. So yes, here you will have the methyl above. The molecule is going to look somewhat like this. Now we have to be careful while we are checking the stereochemistry of the product. ठीक है? Yes, ये देखो, ये हम क्या कर रहे हैं, एसिड को चेक करेंगे. एसिड एंड दिस मिथाइल, this acid and the methyl, these are both going to be on the same side. ठीक है, methyl and carboxylic acid, they are going to be cis to each other. So let's check कि adjacent carbon पे और methyl और carboxylic acid, both of them they have to be cis. यहाँ पे trans है तो ये wrong है. Here also it is trans, so it is going to be wrong. In option number 3 we can say it is correct. Option number 4 also correct. Both the methyl and the carboxylic acid should be on the same side. Now about this junction, you see ये वाला जो junction form हो रहा है, ठीक है, this side and this side, both the hydrogens are pointing in the same direction. दोनों इसी direction में point कर रहे हैं. That's why it is going to be cis. तो ये जो यहाँ छोटा सा detail है, this little detail we cannot miss. It is not going to be trans. It is going to be a cis junction. ओके, बिकॉज दिस हाइड्रोजन इज ऑल्सो एक्सो एंड दिस इज ऑल्सो एक्सो, तो दोनों हाइड्रोजन सेम साइड पे हैं. ठीक है. All right. So again, let's check. Acid and methyl on the adjacent carbon are on the same side. The junction is a cis junction. Also, ये जो methyl है और ये जो hydrogens है ये भी सारे के सारे cis है. So we have to check the relative stereochemistry of the product. Answer is option number 4. While following the endo selectivity. Endo rule follow किया है हमने. ठीक है. चलो नेक्स्ट क्वेश्चन करते हैं. अच्छा क्वेश्चन था ये. सिमिलर क्वेश्चन. यस युवराज, यहाँ पे क्लासेस बंद नहीं होगी, बिल्कुल नहीं होगी, क्योंकि अब मेरी प्रायोरिटी मेरा चैनल ही है, डोंट वरी. और राइट, सो मैं क्लासेस अगर मैं खुद ही प्रोवाइड कर रही हूँ तो मैं ऐप में करूँ या फिर मैं यहाँ पे करूँ, वो मेरे लिए एक ही बात होगी. ठीक है. सो बोथ ऑफ दीज थिंग्स विल बी माई प्रायोरिटी, डोंट वरी. ऑल राइट, आ जाओ गाइज, नेक्स्ट गुड क्वेश्चन. अबव बिलो में बहुत कंफ्यूजन है. यस प्रियंका, अनवय, स्टीरियो में आंसर गलत हो जाता है. यस प्रसाद, समटाइम्स. ओके. सी, there is only one convention that we have to follow, guys. Always keep the diene on the top, dienophile on the bottom, and whenever there is electron withdrawing group, keep it in the endo position. मतलब इसके नीचे रखना है endo position पे. फिर उसके बाद में चाहे जो हो जाए, जो भी ग्रुप्स है जस्ट कंपैरिजन करो और रखो. थोड़ा सा प्रैक्टिस चाहिए इसके लिए. इट इज नॉट वेरी डिफिकल्ट, यू जस्ट हैव टू बी एबल टू सी इट नाइसली. ओके, वही प्रैक्टिस मैं करवा रही हूँ. ओके, सो स्टीरियो ऑफ Diels-Alder is not at all difficult, it is very easy. विल डू फ्यू क्वेश्चंस और उससे आ जाएगा आराम से. Yeah, what about this one? Okay, we can do this one thing. We can try out two possibilities. So which is a more electron rich carbon over here? This one or this one? Which is a more electron rich carbon? देखते हैं. This methoxide is giving electron density all the way to this particular carbon, right? ये ऐसे ही resonance करेगा. Also, this oxygen is giving electron density to this. According to the substituent, this carbon is the most electron rich carbon, right? And what happens over here in the case of this ester? Ester is pulling electron density, even though it is not pulling like this. Minus R, चलो नहीं भी मानते हैं तो minus I है. According to that, this carbon is the most electron deficient. ठीक है. तो according to that, I am just trying to make a regioselectivity decision कि ठीक है, more electron rich is going to combine with the more electron deficient. यही करके देखते हैं. This is OSIMe3. Alright, there are two methoxy over here. And the reaction took place with an alkyne which is going to give you an alkene. ये हो गया cycloaddition, one of the possible choices. Now here I have not given you acid or anything. मैंने आपको acid थोड़ी ना दिया, नहीं दिया है ना? Yes, I have not given you acid, guys. So it is going to be as it is. Answer is option number 1. ठीक है. अगर मैं कुछ aqueous workup or anything if I am doing, then I have one more option. In the presence of acid and water, This is again your silyl vinyl ether and this is again going to do the hydrolysis. कैसे करेगा फिर ये hydrolysis? ठीक है, this is going to take away a proton. There is a bond, it's going to push off like this. या फिर एक और काम कर सकते हैं हम, इसकी जरूरत ही नहीं है, इसको हम ऐसे भी पुश ऑफ कर सकते हैं इस तरीके से, बट फिर भी एसिड चाहिए बिकॉज methoxy will not leave by itself, isn't it? So even if we want to make this leave, even if we want to get this product option number 2, we need an acid to make this methoxy a good leaving group. तो चलो नहीं है acid, हमारा product option number 1 ही है. Okay, so our correct answer is option number 1, not 2. Got it, guys? This was the trick over here. We don't have acid. We have nothing. कोई solvent mention नहीं है. So 1 is the correct answer. We stop only after a Diels-Alder reaction. Okay, chalo. Next one. Oxygen lone pair can push the leaving group. But what is the factor? What is the driving force? Methoxy भी अच्छा leaving group नहीं है. If there is an acid, then only the methoxy is going to leave, no? ये शुभदीप. और यहाँ पे भी ये why is it going to push? इसको क्यों push करना है इसको? अगर एसिड होता या वाटर होता जो इस पे अटैक कर रहा है तभी तो पुश करता ना. नथिंग इज मेंशन्ड. चलो अभी आओ इसमें स्टीरियोकेमिस्ट्री ऑफ सिग्माट्रॉपिक रिएक्शन. लुक एट द स्टीरियो ऑफ द मिथाइल्स. यू नो इसको कैसे बनाएंगे हम? ये सबको आता है ना, 6 मेंबर्ड चेयर ट्रांजिशन स्टेट. All right, we have actually got two possibilities over here. क्योंकि ये दोनों मिथाइल क्या है? These methyls are trans. So what are the two possibilities? I can keep the methyls on the diaxial position in the chair conformation. ठीक है, this is going to be trans alkene and this one is a cis alkene. एक हम इस तरीके से लिख सकते हैं इसको, और हम एक और तरीके से लिख सकते हैं. ठीक है, let's say I'm flipping this. मैंने इसको flip कर दिया. अगर मैं इसको flip करती हूँ, if I flip this, the same carbon is above, this methyl group is above, but it is going to become equatorial. मैंने इसको गलत लिख दिया, sorry. This is very irritating all the times because you have to take care of this M and the W of the substituent, right? So methyl equatorial goes here. And this is also going to become it is axial. Now it goes equatorial, so it goes like this. Okay. Now where is going to be this double bond? This double bond is over here and one of the methyl is trans. तो ये trans हो गया है और ये वाला जो double bond है ये ऐसे आएगा. And since this methyl is going to be axial, तो हमें थोड़ा सा change करना पड़ेगा. Okay, we have to write it axial like this. Okay, slight difference between both of these. No, it's not an in reaction, it's a 3,3 sigmatropic rearrangement. देखो, it is a simple 3,3 sigmatropic rearrangement like this. ठीक है, ये इधर थे, ये इधर आ जाएगा double bond. But the question is that what is the stereochemistry of these methyl and these methyl? उसके लिए हमें ये draw करना पड़ेगा. Okay, Hina, we have to draw this. Now, if we are, let's say, I am trying to make a point over here. If we are taking the two methyls in the diaxial position, Then let's move the bonds and let's write the product. Both of these methyls are going to be on the same side, लेकिन आपको थोड़ा सा ध्यान रखना पड़ेगा that this is an unstable possibility. This is not going to form. Why? Because when there is a possibility of conformational change to a more stable conformation, तो डाईएक्सियल फॉर्म नहीं रहेगा इस मॉलिक्यूल का, इसीलिए ये जो प्रोडक्ट है जो यहाँ बन रहा है, दिस विल नॉट फॉर्म. Okay, it will rather flip to the di-equatorial form. और अब यहाँ पे अगर हम रिएक्शन करते हैं 3,3 सिग्मा ट्रॉपिक चेंज करते हैं, then it is going to look somewhat like this. अगर पूरा एग्जैक्ट सेम भी नहीं आ रहा हो तो भी कोई प्रॉब्लम नहीं है. We just have to be careful about the stereochemistry. This carbon and this carbon is right over here. They have formed a new sigma bond. Both the methyls are on the same side. They are both above. Just be careful. दोनों methyl above है. And this one is going to form a transalkene because of its position as chair. Chair क्यों बनाते हैं हम, ताकि हमें पता चल जाए कि वो equatorial है या axial. Right? And this one over here is also going to form a transalkene. Like this. So your final product, अच्छा सॉरी, ये सिस बनाएगा क्योंकि ये बॉन्ड इस तरफ है. All right, let us check once again. This is the methyl. Both of these methyls are going to be above. These are the two bonds. ये एक methyl इधर रहेगा. And I guess if I just connect the dots over here and the double bond has shifted, yes, you are going to get a trans one. तो ये bond इधर जाएगा, ये methyl इधर जाएगा guys. Okay. All right. So definitely it's not benzene. और ये इस तरीके से तो डेफिनेटली नहीं लिखा जाएगा. आंसर कुड बी 1 और 2. अब दोनों में क्या डिफरेंस है 1 and 2 में? That in 1 you have got them trans, in 2 you have got them on the same side. So while you are writing the chair conformation, proper chain conformation of the di-equatorial form, you are going to say the answer is option number 2. Okay. So through this 6-member transition state, we are able to decide what is the stereochemistry of any 3,3 sigmatropic reaction. ये कौन सा reaction है? ये cope rearrangement है, simple cope rearrangement. Alright, चलो, let's move onwards to next very awesome question. Again taken from Caruthers. अभी recent में आया था ये question, बहुत ही recent में आया था. Yes guys, try this out. What kind of a cycloaddition is this? वन थ्री डाइपोलर नहीं. Benzene. But we don't have benzene here. No, it's not benzene or a triple bond. If you want to say that. There is one thing which is very, very special. That is addition of allylic cation or allylic anion to a diene. Okay, so यहाँ पे diene तो simple diene है ही, but the dienophile is a allylic cation. How are you going to explain that? Allylic cation is being added to a diene. OTF बनेगा, yes. There is an OH. What is TF2O? This is your triplet anhydride, तो ये बन जाएगा OTF. Alright, after the formation of OTF, it is going to leave. But what is the driving force of OTF leaving? आपको पता ही है OTF is bulky, so it can leave. Okay, ब्रोमीन को देखते ही हटाने की जरूरत नहीं है, पहले पूरा समझो. कई बार ऐसा होता है कि हाँ ब्रोमीन तो लीविंग ग्रुप है, ब्रोमीन को हटाते हैं, but why? So only one positive charge over here. Now what? Now this is the allylic cation which is going to add to this. ओके सो यहाँ स्टीरियो की जरूरत नहीं है इतनी कोई ज्यादा. यहाँ पे आपको ये समझना है दैट हु इज अटैकिंग whom, व्हाट काइंड ऑफ अ cycloaddition इज दिस. ये Diels-Alder जैसा ही है, only a little different. So this carbon and this carbon we are going to attach. How many membered ring forms? 1, 2, 3, 4 and 5. You will get a 5-membered ring over here. ये तो है ही इसी तरीके से. So this is going to also add over here. The bromine will stay as it is, not going anywhere. ये रहा डबल बॉन्ड. बीच वाले कार्बन पे पॉजिटिव आएगा because here this double bond attacked over here and this double bond attacked. तो बीच वाले कार्बन पे पॉजिटिव आएगा. But there is a methoxy. So methoxy is going to stabilize this over here और ये methoxy का जो OMe bond है, this is going to break down and the OTF is going to attack over methyl. Let's say for example methyl is going to be lost और ये यहाँ आ जाएगा as a carbonyl. So this is going to be a carbonyl. Now what about stereo? OH नहीं रहेगा. OH तो पहले भी यहाँ नहीं था, so OH is not going to stay over here and Br will not be lost. So 1 and 4 are absolutely wrong. ठीक है? Yes. 1 and 4 are wrong. अब चलते हैं 2 या 3. Which one is going to be the correct answer? Yes. Now let's look at this. अब stereochemistry पे चलते हैं. चलो. Now here, see again we know that all of the reactions are pericyclic reactions are concerted mechanism. So there are 3 bonds already over here and there is a positive charge, right? और ये डाइईन है, ये वाला डाइईन को हम ऊपर की तरफ रखेंगे. We keep the diene above and this part is the dienophile part. This is going to be below, where the oxygen is already below this whole thing. Fine. So if we keep the this diene part above and if we keep this whole thing below, then the new bonds which are formed, ये below की तरफ form होने चाहिए. Do you understand this, everyone? That these two bonds which are formed, they are going to be below the ones which are formed over here, like this. Okay? If these bonds are below and one carbon is tetrahedral, तो अगर मैं इस वाले कार्बन को पकड़ूं और इस वाले कार्बन को पकड़ूं, ठीक है, तो एक कार्बन टेट्राहेड्रल होता है. मान लो कि अगर मेरे पास में ये दो ग्रुप on the plane of paper है, then one of the group is below and the other group is above, right? So these two are on the plane of paper. Let's say this group is above and this is below. Similarly, these two are on the plane of paper. Let's say this is above and this is below. इसका मतलब क्या हुआ? It means that this is stereochemistry. It is not trans. ये trans नहीं हो सकता. 2 is wrong. Okay, the answer is going to be option number 3. Okay. Why is that so? Because we are forming a concerted mechanism. Diene को above रखो, dienophile को below रखो, and you will be able to understand from there. Got it? 3 is going to be the correct answer. Very simple question. So what kind of a cycloaddition it was? Allylic cation adding to a diene. Okay, that's why you got a 7-membered ring. This is a 7-membered ring that we get. All right. I hope this makes sense to everyone. Yes or no? Okay guys, that's it for today. आज के लिए हम इतने ही क्वेश्चन करने वाले हैं और भी काफी सारे क्वेश्चंस हैं. Let me check if I have any more question. हाँ, एक और क्वेश्चन है, ये वाला कर लेते हैं. One more question we have. Let's do this as well. What do we understand from here? ये हमारा लास्ट क्वेश्चन है आज का. All right, what does it look like in the presence of light? Very nicely answered, all of you guys. So, in a 2 plus 2 cycloaddition, we know कि ये 2 plus 2 ही होने वाला है. This is not a Diels-Alder reaction because there is light. So, when we are considering light, we can also consider the contribution of radicals. तो मान लो कि ये radical mechanism के through जा रहा है. If we connect these two groups like this, okay, then we are going to have a diradical in this way, which is going to be the more stable possibility. यहाँ पे भी ये जो radical है, this is stabilized into the double bond, and here also this radical is stabilized because of the resonance from this oxygen. So that's why this regioselectivity is going to be followed. ये वाली regioselectivity follow होने वाली है इधर. That is the oxygen. This is going to give you 100% of the product, no major minor. ये ही product बनेगा. This product is not at all forming or 4 plus 2 is not happening. Okay? All right. So, yes guys, जब आपको पता होती है कुछ चीजें कि ये ऐसे ही होता है, when you have seen some of the reaction in your books, then you feel more confident in answering the question, right? तो इसीलिए books में देखना, books के example देखना बहुत जरूरी है. Okay, so once in a while just open the book and go through the examples. Okay, it's nothing like कि एक book को पूरा पढ़ना पड़ता है, कोई नहीं पढ़ता पूरा book को, just go through the examples. Okay, that is going to be good enough. All right. Chalo guys. So yes, I'm going to take a leave for today, and as I said कि हम लोग daily session करने ही वाले हैं YouTube पे, no matter what. But also guys, very soon I will be launching a crash course both for organic and inorganic. It's going to take me like few more days. ये crash course जो है, this is going to be mostly based on practice, and very soon I will also launch a test series for all of you, जिससे आपको थोड़ी सी help हो जाए, ताकि आप last minute practice करके अपना जो exam है वो crack कर सके, because I think that these two things are going to be really helpful for all those who are like just about to qualify the exam. Just 10-20 marks का फर्क है खाली, ठीक है? So okay, so I think that is going to be more helpful. Not on YouTube. It's going to be basically on an app. Just working on it. Yes, Prasad. And right. Let's see how it comes out, and how you guys are going to use it. देखते हैं, थोड़ा सा टाइम और लगेगा उसमें. It is Paterno-Bucchi reaction. Paterno-Bucchi भी consider कर सकते हो. Basically, what is Paterno-Bucchi reaction between a carbonyl and this alkene? That is Paterno-Bucchi. And a Paterno-Bucchi is a 2+2 cycloaddition in between a alkene and a carbonyl, right? So you can consider it both ways. Not a problem. Chalo. Now, all right. Yes. I know you all are waiting, and it's going to be a very awesome crash course, very helpful for all of you. बस 2-4 दिन का और wait कर लो, and we are going to start the practice very soon. All right, guys. So that's it for today. And for those who have not watched all of these sessions, please do. Live classes are already made for all of you. Daily live session होने ही वाले हैं. Okay. 6 बजे के टाइम थोड़ा सा नेटवर्क खराब हो जाता है मेरा, इसीलिए थोड़ा इश्यू आ रहा है. But this time is also good. Just stay updated about the time. Just stay connected with me in the group. ग्रुप में सारी सब चीजों का टाइम मैं भेजती रहती हूँ आपको. All right. Yes. So it was nice. It was a nice session. Nice seeing all of you. I'll see you all tomorrow now. Have a nice evening, guys. Very good night. Bye, everyone. Take care, all of you, and keep practicing. Bye bye.